Good afternoon, ladies and gentlemen. As an IT director, I've been asked by my company to present a mitigation strategy in identifying common attacks used against a company. So today, I'm going to do a PowerPoint presentation where I will be sharing my screen using the PowerPoint to elaborate mostly on these mitigation strategy. I will urge you all, audience, to give me your undivided attention as I go through with my presentation. Thank you. Okay, thank you, ladies and gentlemen. Um, as we get to the introduction of this, understanding vulnerability analysis. So this gave you an overview of what vulnerability analysis is. And I'm not going to read word for word, but I'm just going to summarize this presentation at its mostly focus on the impediment and also the mitigation strategy we're going to set in place. Now, cybersecurity hinges on understanding and addressing vulnerability within system. Vulnerability analysis is the process of identifying and mitigating security weakness at the foremost of a defense. Now, that is the main axis of vulnerability analysis because, like, if you are doing pen testing, and for some of us from the devil's domain, most of the time that in our security team, they have a pen test as to do as part of their testing strategy, especially when they are doing scalability testing and load testing. So the pen testing is to identify those vulnerability. Now, from my personal experience in my current organization, I build CI/CD pipelines and integrate some security features in it for testing purposes. If you ever heard about Oracle Scan and Southern Cube, so whenever we are meeting some deadlines, we have to present these vulnerability reports to the leadership of the company and to the security team. So that is exactly what we mean by vulnerability. Vulnerability simply means that we want to identify the weakness of the company in terms of the technology stacks and then introduce a mitigation strategy. So it's security weakness. That's all it is. Security weakness identification. And then after you identify the security weakness, and then you go about mitigating those security weaknesses. Now, in our approach of mastering these skills, we embrace a hands-on methodology. Virtual machines provide a secure environment for practical learning for our purpose. Now, in the real time, that's what we have done. We kind of enable that environment to make sure we go about our testing. So this is the first part. So understanding how vulnerability can be exploited is crucial in the segment. We delve into the process of gaining root access into a Capra one machine, employing various methods to underscore the potential risks. So that's what I did. And mostly that's what the protocol was all about. From the learning perspective, we were able to gain root access to the Capra machine. We created a user and we came across some hiccup that has to do with host not being found. But that is a different story. But that was the goal, that was the aim for us to identify vulnerability by gaining access to the Capra machines and creating a user using the Samba. Now, and then previous escalation, right? Previous escalation is very, now these are the buffers, these are the common security attacks. Previous escalation is a critical concern in cybersecurity, where unauthorized users gain elevated access beyond their intent level. Understanding its significance is pivotal in devising effective mitigation strategy. Now, Let us introduce ourselves to privilege escalation. Privilege escalation involves the unauthorized elevation of user privileges, potentially leading to the compromise of critical system components. This can result in severity of cybersecurity breaches, emphasizing on the need for proactive mitigations. That is what we refer to as previous escalation. Then we go to mitigation techniques without upgrading and replacing system. Addressing previous escalation without the option of system upgrade or replacement require innovative strategy. Here are some of the key techniques. Now, the key techniques to be able to identify and these techniques without upgrading, like any replacing system or doing any patching. Now, we have something we call regular audit, right? Regular audit and monitoring. We have to monitor the environment. We have to audit on a quarterly basis. We have to monitor. We have to deploy a lot of monitoring tools in place to monitor the environment. And the good thing is that in the industry right now, we have a lot of tools for monitoring. We have Splunks that are looking at logs, log aggregations, Signal FX, Splunk Cloud. We have Grafana, we have Prometheus, we have all these monitoring stacks that give us tear eyes into the system. So this is very important. Then we hope of strong authentication mechanism, implementing robust authentication measures such as multi-factor authentication can be very useful. Now we all know what multi-factor authentication is. For those of you of the cloud environment, AWS uses the multi-factor authentication, Azure uses the multi-factor authentication, and that is very, very important to be able to mitigate most of these things in terms of deploying multi-layer security within your organization. Challenging posed by limitation on system changes. This is one of the main aspects as well. Then we have limited patching options. So patching, inability to upgrade and restrict application security patches, leaving system vulnerable to a new exploit. If you don't patch your system, if you don't update your system, you're just using version 1.0, always end of life, you're still using that version. Sometimes you observe that version is being in the alpha state and people use the alpha state in production. So these are all of these things that we have to take into consideration as well. Now, then we also have dependency and legacy system. Legacy system may lack modern security breaches and system functionality. Striking battles between security measures and the lead system functionality become crucial when extensive changes are not viable. Now, these are all of the factors that contribute to vulnerability. These are techniques that we have to deploy as a cybersecurity analyst. By deploying these techniques, we can ensure that the system will be well functioning and everything will be in tight. Now, then we have buffer overflow. Definitions. Buffer overflow is a type of vulnerability where a program or process attempts to store more data in buffer temporary data storage than it was allocated, leading to the overflow of excess data into the adjacent memory locations. Now, this is one of the contributor factors. Then we have summaries. Buffer overflow are the preventables of potential abilities and dangerous forms of attack, often exploited and injecting malicious code into the program memory. This can also lead to wide escalation and unintended commands, compromising the security and stability of the system. Now, it's very important for us to acquaint ourselves with most of these techniques as a cybersecurity engineers. This will open our mind as to how we can explore the system, as to how we can know all of these things. And not being ignorant as a cybersecurity engineer, you have to know these things and you have to know how we can mitigate or put this strategy into place. Then we have summary. Buffer overflow are the prevalent and potentially dangerous form of attack, often exploited by injecting malicious code into the program memory. That's what happened. Now, people would inject code into a program, and that program with malfunctions, and it enabled them to take control of that program. You see, then we also have categorization. Buffer overflow are broadly categorized into two types. We have the stack-based buffer overflow, and we have the heap-based buffer overflow. So the stack-based buffer overflow involves overwriting the stack memory and exploiting local variables and functions return addresses. Then the heap base occur when the data in the heap memory is overflow, injecting dynamically allocated data. So these are all examples and of our buffer overflow. So this is part of the taxonomy of attacks. And as a cybersecurity engineer, like I previously said, we have to acquaint ourselves with all of these happenings. Now, we have the taxonomy of attack part 2. We have rookies, Trojan, viruses, and all of these things. Now, you can go about naming it. I have listed a lot in my presentation, but I'm not going to call them word for word. But as we dive into the presentation, reading this presentation will give you more insight on what all of these things mean. Return-oriented programming, our DP, commodity social engineering attacks. Return-oriented programming definition. ROP is an exploitation technique where the attacker utilizes existing code fragment known as gadget and construct a malicious sequence without injecting a new code. That's what this meant, like ROP, exploitation techniques, and this is the dangerous part because this is where attacker will stand in the position of constructing a malicious sequence without injecting into a new code. So these are all dangerous form of attacks. And we also have like common social engineering attacks. This is very common among our social activities like Facebook, like all of the areas hackers use the means of gaining access to system through social engineering. So this is very common among our communities and in our surrounding today. Thank you very much for giving me your undivided attention, for going through this presentation. And I'd like to take this time to give all of my audience a very big thank you for this. Thank you very much.